Alright, now here's what I want to do right here is I want to back up for a second and I want to reintroduce to y'all concavity, okay? Now, let's look at this picture right here and let's talk about the basics of concavity, okay? Now, we know right here there's a minimum, okay? And we know right here that there's a maximum. But we're not talking about extremer here, are we? Okay, concavity means that the graph, what I like to tell people is, if it were to rain, if the puddle of water would build up in the graph, then it's concave up. Okay? But if it were to rain here, the water would just run off, and so it's concave down. Okay? Now, the question is, where does concavity change? Well, in this case, it's going to be somewhere about right here. Okay? That location where the concavity changes is called the point of inflection. Okay? Now, points of inflection occur when the second derivative is equal to 0 or when the second derivative does not exist or is undefined. Okay? So those are the two ways you're going to be able to calculate a point of inflection. Now, why that's important is no longer do you have to search a graph or zoom out or zoom in looking for your points of inflection. If you can calculate where the second derivative is equal to 0 and where the second derivative is undefined, you'll know all the locations of the possible points of inflection. Okay? Now, the point of inflection is where the graph changes from being concave in one direction to being concave in the other. So you can see that this graph is concave up from negative infinity all the way to whatever this point is. It looks like maybe x equals 1. Okay? So we would say that the graph is concave up from negative infinity, and we're approximating x equals 1. Okay? And then at 1 it begins being concave down, and it's concave down from that 1 all the way to infinity. Okay, let's look at and study the concavity of this graph. Now, you can see that the graph right here is concave up, okay, and the graph right here is concave down. Okay, now you can clearly see that there's a vertical asymptote at whatever x is right there. Okay, so now you can understand why the concavity changed there, right? There is no point of inflection in this graph. I guess you could say the vertical asymptote is the point of inflection. Okay, but in this case, the concavity changes at the vertical asymptote. The graph is concave up here, and it's concave down here. And the place where it changes concavity is whatever this vertical asymptote x value is. And it may not even be a vertical asymptote. It almost looks like in the graph that this may be a slant asymptote. Okay? But we haven't done the problem. I'm just showing you in the graph what concave up looks like and what concave down looks like. Alright, this graph has multiple locations of concavity. You can see that the graph is concave up all through here, but somewhere right in here it begins being concave down. You see that right there? So this section right here is concave down while all this is concave up, right? And then if we look to the right of 0, you can see that this section's concave up, but somewhere around right here it begins to be concave down. And so you can see that water would collect through here, but if it rained on this portion, it would just run off. Okay? And so that's just a little way that I've always taught concavity. You can see here that the water would collect, but if it rained here, it would run off. And so you can see that's clearly concave down, where this is clearly concave up.